The critical line of the zeta function. This is actually my first attempt to understand that equation S is equal to sigma plus I, imaginary, and then interval. And now I'm visualizing the real part, the cosine, the x-axis, and the imaginary part in the y-axis, or the sine, S-I-N-E, is the sine wave that moves the line up and down. And so the intervals, the t intervals, are also in the x-axis, and as we increase the intervals, we're also decreasing the real part, the cosine part. So it gets closer and closer to zero as we increase the intervals. And so once again, I'm using number of digits, but this time, since it is, less than 1, the digits here are the number of zeros before the leading non-zero digit. So if it is 4,000, then there's 4,000 zeros before the leading number. And the leading non-zero number in the x-axis for the real part is actually affected by the sigma used. So the zeta function, where we find most of the non-trivial zeros, we use the 0.5, but it can be any other number. It can be 1, 2, 3, or 0.15, and then it will show you what the leading number for that, given what you enter the sigma. It doesn't seem to affect the y cosine. It's the y sine, S-I-N-E, that seems to be affected more of the intervals, the t intervals. So what makes this equation different is that you're plotting the cosine and the sine. The sine, even though it's for the same, it changes negative, positive, the sine wave. So it creates all those peaks and then bottoms, That's what the sine does given an interval, and it doesn't do it equally. Sometimes there's more it's more positive, sometimes it's more negative. And so you might think, so what's the point then? Because as you increase the t could be 10,000, and you still see the same chart pattern, which is that it's going to get closer and closer and never actually in zero, never actually meeting zero. It's just getting, the zeros keep getting larger and larger, but as you can see, it can go up to maybe even a million zeros. So so it just, as you can see, it loops through different intervals, increasing intervals, and that's just what's going to happen. It doesn't have to be by a range of more than 1. You can also just enter 1, and you can see the up and down even more closer. So what is really, so it's not just the t getting larger. If you want to see this zeta function, like I said, if you even go to the database, there's so many intervals that contain a zero function, the one that cancels out both the x and y. So that's not really the point. The point is at what increment of the interval, at what exact value, which contains decimal points, even 20 digit, or maybe more zeros. So very small, what small number increment that really affects both the sine and the cosine, especially the sine, that gets it closer to zero. So if we zoom out, we see both x and y getting closer to zero, but there are actually twists and spirals happening in different in the smaller range.